Hey, what's up everyone and welcome to Daily Code Buffer. In this video of scalable thinking, we are going to learn about the quad trees. We will understand the applications of the quad trees and where those are used, and we'll also understand the implementation of it and how we can write a code for quad tree as well. Now, quad tree is very important algorithm in terms of your system design interviews as well. So make sure that you understand this algorithm and it will be very helpful in your implementation phases. It will not be asked directly, but you should know the implementation of it, which will be very helpful. Now let's take one scenario. Here you can see that on my screen you can see a map here, and what I want to do is I want to have a food delivery system where I want to find the nearest driver for me, nearest delivery partner who can deliver the food for me, which can pick up from the restaurant. Okay, that's what I need. So suppose I am at this location. Consider I am here, and there are food delivery partners who are available here, available here, available here, and so on. Now to get a delivery partner for me, what I can basically do is I can search within a radius. And whatever the delivery partners are available within that radius, I can check all those delivery partners, and whoever is nearest one, I can assign that delivery partner, and that particular delivery partner can get the food for me. Now suppose you can see that out of this delivery partner, by the look of it, seems very near, right? But if you see that this delivery partner, though it seems very near, but it has to cross a railway crossing, okay, or an express highway, whatever it is. So that delivery partner has to go and take a long U-turn to deliver the food. Now this particular long U-turn distance will increase the time and it will increase the distance as well. It might be better that this delivery partner could have delivered food quickly, or this could have delivered food very quickly. Now this is a problem where we cannot directly search the nearest drivers available, nearest delivery partners available within the radius. So in that case, we need to come up with a different algorithm, different search criteria to find the nearest delivery partners for me. Now this particular algorithm which we can use is quad trees to implement it. Now how quad trees work, we will see. Now let's take this map and let's try to implement a quad tree. Now quad tree is a combination of quadrants. Okay, so suppose this is a square available or a rectangle available, then what I can do is I can divide this into 4 quadrants. So one line here, one line here. So now you can see that I have divided my rectangle, my square, into 4 quadrants. So this is my quad tree. So if I represent this as a graphical way, it would be like this is a node, this is a node, and it has 4 different nodes. Okay, this is a representation of your quad tree. Now this representation will be this way. So it will be, this will be your north, this will be your south, this will be your west, and this will be your east. So this quadrant will be your northwest, this will be your northeast, this will be your southwest, and this will be your southeast. Okay, now, and your location would be somewhere here. It will be consider 0, 0. This is your center point. Now suppose if you want to identify the driver location or how many drivers are there nearby, then you can get within this particular quadrant. So suppose let's put some drivers here. So one is here, one is here, one is here, one is here, somewhere here. So now if I have to identify, what I can do is I can search all those within the quadrants here and I can easily identify. Now this particular area can be really huge, right? Because you can see that we have consider an entire Mumbai here, but you want to have within a very specified range. So suppose if you want to get all the data within this specified range only. Okay, so this is what you want the data for. So I want all the drivers within this range only, because I do not want to search for the entire Mumbai. I want to search within a kilometer. If any of the drivers are there within that kilometer I want to search. So if you want to search within this particular area, then you need to search from your point to this particular rectangle that how many drivers are there nearby. Okay, so for this you can see that you won't be able to identify directly because this particular driver is a part of this whole entire northwest block. So that means when you are trying to search this, all those drivers will be there and you need to have the conditions check where it should be within this boundary as well. And now if you want to go to the granular details, what you have to do is you have to further divide this into smaller chunks. So suppose if I have that, I can only have one driver within this box. Okay, and if there is another driver that I want to add, then I need to divide this part into furthermore. So what I can do is I can again go and divide this. So I will go and divide this and I'll go and divide this. So now you can see that within this quadrant, now you are again dividing into 4 quadrants. So here you can see that if I see this particular block is now divided into another 4, 1, 2, 3 and 4. So now you can see that this is again divided into 4 blocks. Now suppose if you are still dividing further, you can. So let's divide that as well. If I'm dividing this, I can divide this. Okay, again I have divided. Now that way again I can divide here. So I can divide 1, 2, 3 and 4. So now you can see that a two-way representation, how the graph would look like, how your quadtree has been prepared, and on the two-dimensional plane, how your structure has been looking and how you are dividing the data, how you are dividing the area into a quadtree, into a smaller blocks. So now you can see that we divided an entire Mumbai, entire location into 4 quadrants. And each quadrant again divided into sub-quadrants and again divided into sub-quadrants and again divided into sub-quadrants. Now till where you can go. So if I want to go further from here, right? If I want to go further from here, I can do still. I can do this. If I want to divide further, I can still do this. I can still divide further. Right? I can go till recursively to divide this further. Now till how much I want to divide. This division can be based on the numerous condition. Suppose you are having a condition that in each quadrant I should have at least one driver. So if that particular criteria is met, you can divide accordingly. If you see that, if you consider that my each block should be of this much size, maybe 500 meters by 500 meters. If you achieve that, you can stop there and you can continuously do until you find this. Now this is at very high level how we are doing this, where we are dividing an entire region into 4 quadrants and again that particular quadrant into again 4 quadrants. Okay, so this is something that we are dividing. So this is how you represent the data in a data structure, so you can find all the relevant drivers, all the relevant points nearby to that particular location. This is how it is. Now how we should represent this in a code. So let's take the example that this is a point. Okay, this is my point. So I will represent this as a point. And this point will have x and y axis. Okay, x point and y point. This is my point. Now based on this point, you can create a region. This is your region. This is your rectangle. Okay, so I can create a rectangle. And this rectangle will contain your point, that is your center point, that is your x, y, and it will have the distance for that particular rectangle. So that distance will be in the half. So it will be width into half and height into half. You can represent this in any way, but this is what I'm trying to represent, that I am creating a point. This is my point. I am creating a rectangle. This is my entire rectangle where I am storing the point, that is my xy coordinates, and I am giving this particular location, this location, and this particular size. These two size I am storing. This is the two things I am storing. Now I can represent a quad. This is a quad tree that I am representing as a class. Now within this quad tree, what I would represent that within that quad tree, how many points are there. So I'll just define list of points. Okay, so that means that if this is the quad tree that I'm considering this particular northeast, within this northeast, how many points are there? How many delivery partners are there if we're talking about the delivery system? Okay. Now it will also define its boundary. So it will have a rectangle as a boundary. So it will have x-axis, y-axis, width by 2 and height by 2. That means it will define a point. So within this quadrant, so if we take this quadrant, this will define this particular entire quadrant. So it will define that what is my center point and what is my width and what is my height. Okay, of a single quadrant out of those 4. Then it will define its capacity. That means how many points it can contain. So this contains the list of points available, and this is the total points it can store. So if the capacity is 4 and if you are storing 2, that means that out of 4 capacity 2 are there and 2 it can still store. Then the next thing I will define is this particular quad tree is been still further divided or not. So it's divided or not as a bull. Okay. So this is what I am storing now. So hope you have got the idea that I am storing a quad tree. This quad tree will contain a list of points available. So it will contain a list of points available 1, 2, and it will have this rectangle boundary. So it will have this entire boundary here. Okay, and it will have the capacity, like how many total capacity is there. Suppose total capacity is 4. So it will store 4. And is this particular divided or not? So currently you can see that northeast is currently not divided. So it will store that it is not divided. But suppose if it's still divided further, right? Then it will store that it is still divided, and accordingly we can go through. So this is how the structure would look like. So this is what I have defined. Now I will just define this as a north, south, west, east, and this is your point. Okay, that is 0, 0. Now I want to create a quad tree. Okay, so suppose I want to create a quad tree. So my first quad tree I can define such a way that I want to create a quad tree, okay, based on the above attributes. Okay, what is my points, what is my rectangle boundary and everything. So here I can define that I want to create a quad tree where my x and y are 0, 0. Okay, that is my rectangle, and my height and width is 100, 100. That means my this height and this width is 100, 100. That means, so which will have a complete rectangle of 200 by 200. The total capacity is 1. Okay, so that means I can store 1 point in one particular box. That's it. I'm just creating a quad out of it. Now suppose I want to do an insert operation here. Okay, now it says that insert a point here. Let me write it's 200 distance here and 200 distance of here. Okay, so now here you can see that it is asking to insert a point at 50, 50. Okay, so that means something, this will be 100, this will be 100, somewhere here. Okay, so now I want to insert a point here. I can easily insert a point here, right? Because it is within this particular boundary. So I can check. Now whenever I'm trying to insert a 50-50, I need to check that if that particular point is within this particular range or not, right? So I need to check that if this point is contained within the range or not. If this particular point is outside here somewhere, then I cannot add this within this particular quad tree. Okay, so that's why I cannot add it. I can just say return, I cannot add it. But if this point is within this particular box, then only I can return. So I'll check that if this particular point is within the range or not. If it's within the range, I will insert it. And while inserting, I will also check the capacity. My maximum capacity is 1. And within my current list of points, I have a list of points available, right? So within this list of points, there is nothing available, and I have inserted 1. So I can insert 1 and my capacity is 1. Done. Now I want to add one more point. Suppose add 30, 30, maybe somewhere here. Okay. So now I will try to insert 30, 30, Now it will check that, okay, if this 3030 is contained within that box or not. Yes, this is contained within that box. Yes, so okay, it will go and check. Okay, now it is contained within the box. Is the capacity full or not? So here I can see that the capacity is full. So that means I cannot add it within this box. So now as I cannot add it within the box, I need to further divide the box to store it. Okay, so what I will do is I will further divide this box to store the value. Okay, so now when I divide this box, I will change divide flag equals to true. So whatever the divide flag I'm storing here, right? I will change it to true so that I have divided. And now once you divide it, what you will do is you will create a 4 new quadrants. Okay, so that means you will create northwest equals to new quad, northeast equals to new quad, southwest equals to new quad, and southeast equals to new quad. Okay, once you do this, your point will be inserted. You need to insert a point within this now. Okay, so what we'll do is you create all this, and within all this you pass a point. That point, this is my point, and I want to add this point in either of this. So why I will add for 4? Because you can see that the point can only go within a single box. It cannot go in all the 4 boxes. Okay, why? Because we always do a contains check. If the point is within here, then only in northwest it will be added. It will not be added in northeast, southeast or southwest, because that particular point is outside that box. So it will be only added 1. So I will call for 4 quadrants to insert that particular point. And now again, if I have to divide, then I will again call the same method, where if the point is even able to add it or not within the capacity. If not, again divide for more particular quadrants and insert into that particular quadrants. So that's how it will recursively create all the different quadrants until and unless only single point is available within my each quadrants. So that's how internally it will divide further into sub quadrants and it will store the values. Okay, so hope you got the idea about how the insertion works within the quad tree and how the structure will be created. So structure will be created very simple. So it will be one quad, one node available. Okay, and this quad will contain 4 different nodes. Okay, so that means this is my region. This is my above region, this one, and this is divided into 4 nodes, that is northeast, northwest, southeast, southwest. So if I want to add anything in northeast, then again it will be added here as a point. And if we want to again subdivide, it will create another 4 points. Okay, then again it will be northeast, northwest, southeast, southwest, again 4 points. Similarly for here. So again it will be divided. So this is how the quad tree will start creating, and it will create a massive structure. Okay, so it was an insert part. Now let's talk about the search part. So let's do search. So now what you want to do, you want to search. So while searching, it is given that search for a driver, so or search for a point here, search for a point within a region. Okay, so now I'm talking about that I want to search my point within this region. Okay, so yeah, here you can see that I'm just giving a search criteria within a region, that within this region find all the different points available or find all the different drivers available for me. Now if this region was here, okay, consider this region was here, then can I find a driver within this region into my this tree? No, right? Because it is not intersecting, or this particular region is not within my main region. It is outside that region. So I cannot search anything. In that case, if it is not intersecting, you cannot search. Okay. So that means I need to have this particular rectangle within this particular area. So maybe here, maybe here, maybe here, or anywhere. if this is intersecting within this particular rectangle, okay, then only I can find it. Okay, that's the first thing. So I need to check that whatever the criteria, whatever the range I have, that particular range has to intersect. It should be within a main boundary. If it is within the main boundary, then only I can start searching. Okay, so now this is my boundary. Now I want to search. Okay, so now what I can do is I will search from this particular to this particular location. Okay, to this. That means my total width minus this, total width minus this. Okay, that's what I wanted to search. So within this region I will start searching, and what I will do is I will check that if any of the region, okay, is within this particular region. If so, are there any points? So this is the region, right? So this is the entire region. If this region is intersecting with this particular part, okay, I will search that, okay, are there any points? Are there any points or not? Okay, if you find any points, that's good, take all the points. You will also check that, okay, if this particular rectangle is been subdivided, because you can see that if the point is available here, okay, while representation you can see that it is part of the big square, but ideally it is part of sub and sub quad, right? So if this particular entire quad is subdivided, then again I have to go through all those sub quad and check if any of the points are available. So here similarly, if this particular point, if this particular sub quad is subdivided or not, and if it's subdivided, if this is subdivided, then I can go to all those northwest, northeast, southwest, southeast, all those particular different quads and search for the different points. So you can see that when you start searching, this particular block will be neglected because those are outside this boundary. This will be selected, this will be selected. Now this two region will also go through this particular search. If the data is available, it will pick. If the data is not available, then it will again subdivide. It will again subdivide, and then it will again search for all those fours where this will be neglected, this will be neglected. So it's within the boundary region, this will be neglected, and sorry, this will be selected because this particular part is there. So this will be selected, this will be selected. You can see that we are doing a binary search kind of operation where we are selecting a quad where we can see the data should be present, and we are neglecting where the data will not be present. So if that particular region is intersecting with our region, then only we are selecting, otherwise we are just neglecting it. Okay, so this way we will go through each and every section of the intersection and we will search for the points. If we are able to find the points, then we will collect those points, or we'll collect the data of that particular delivery partner and we will send the results. So this is how the quad tree will work for search operation. So it will go through the searching until you find the last point where it is not subdivided. Okay, so this is how the entire structure will work. So hope you have got the gist how this entire quad tree structure will work, where you are just subdividing the data into sub problems and you are just searching the data, rather than just having the array where you are defining the which section of the array it will have the value. You are doing the same thing in the two-dimensional form where you are representing that two-dimensional into a single dimensional for easy searching. Okay, now where this kind of quad trees is been used. So quad trees mainly has been used in geo searching. So you can see that this is what we have taken the example for. So when you want to do a geo search, at that time these quad trees are mainly used. Suppose if you want to do any image manipulation, right? In that cases also to find the appropriate pixels, you will use this quad trees to identify all the pixels data. So these are the different applications of the quad trees. There is also a geo hash and geospacing indexes available to do similar kind of things. We will cover that in the different video section. So this is what I wanted to share about the quad trees and how this quad trees works. So we'll go through an example as well, code as well, to understand how this quad tree will work. So hope we will have this picture in mind and we'll go through the quadtree section. So here you can see that I've written a code on the quadtrees and it is defined everything that we have discussed for. So here you can see that we had discussed for a point here which represents the center value of the quadtree. So this is what I'm representing with point class here, which will have x and y value, and it is initializing with the constructor. Okay. Then we have a rectangle which will define this entire rectangle. This entire rectangle is there, right? So this entire rectangle will be defined by this particular rectangle class. And here you can see that what we are taking here is we are taking x and y position and we are taking half the total width and half the total height. Why half? Because as we are taking the center, okay, if we just have the half of this and half of this, we can create or we can identify the rest of the quadrants and rest of the parts. Okay, so that's why we are just taking a center and half of width and half of height. That will represent my entire rectangle, entire square, whatever we are taking. Now within this, you can see that this is how we are taking a constructor and storing the values, but it will see you can also have a value which is contains and intersects. These are the two things that we talked about, like whenever we are creating this, right? So let's see again a rectangle. So let's create a rectangle here. Okay. Now this rectangle is if this rectangle contains a point or not. Okay. So if the point is here, okay. Now this point is a part of the rectangle or not, that we need to identify. So you can see that it is taking a point and we are checking that if this point is part of not. So we are checking that p dot x should be greater than x minus of width and p dot x should be less than x plus width. So that means that whatever the point that we have defined, let's take all the values. Okay, let's take, this is 100, this is 100. So that means this will be 50. This will be 50. Okay. So now what I'm checking is, and this point is also 50, 50. So what I'm trying to do, I'm trying to check this particular contains condition. So my x, which is 50, should be greater than my x minus width. So what is x? X is 50. 50 minus width is 50, which is 0. And here I am saying that my 50 should be greater than equals to 0. Yes, it is. So it is within this range. Then what I'm saying is that my 50 should be less than 50 plus 50, which is 100, which is there, which is 50, right? So which means this is also within the 100. So I'm just checking that it should be within this box, that my value should be within this value and this value. Okay, that's what I'm trying to check, that my total is 100 and it should be within this range. Same goes with height as well. So we will check for all the 4 conditions and we will check that if the point is within my box or not. Okay, that's the one condition. Okay, and then you can see that intersects. What intersects does is it checks that if the rectangle, whatever the range is given, is that range within my main range or not. Okay, so in that case what I'm checking is, let's see, I have a 2 rectangle. This is my one rectangle, and let's see, I have another rectangle. Okay, now I am checking that this particular rectangle is within this rectangle or outside the rectangle. So within this rectangle, what I'm checking is, I am checking the most left part of a rectangle is greater than the most right part of a main rectangle or not. Okay, so if the most left part of this rectangle is greater than the most right part of the rectangle, then it is not intersecting. Okay, so that means that this left part of the rectangle should be less than this right, then only it intersects. Otherwise it does not intersect. Same goes with here as well, that if this is here, that if the most right of this particular rectangle should be greater than the most left part of this particular rectangle. So you can see that this is less than the value, so it does not intersect, so it should be within here, then only it intersects. Same goes with bottom and same goes with top. So we are checking on all the 4 conditions, all the 4 corners, that the value should be intersecting. If it does not intersect, that means there is no point of checking within the range. If it intersects anywhere, then only you can go ahead and check the range. Okay, so that's what the two conditions, two methods are there. Then you can see that this is a quad tree. Now this quad tree, you can see that defines whatever the same thing that we have defined here. Okay, that quad tree will have a list of points. Okay, so you can see that it will have a list of points that defines points contained within the quad tree node, and then it will have the maximum capacity available. Once you reach the maximum capacity, it will try to subdivide. Then it will have a boundary. So this is the boundary that I am talking about. So this boundary is your rectangle. And then is it divided or not? Okay. And then what it will have the reference of all these quadrants, 1, 2, 3 and 4. Okay, so that is northeast, northwest, southeast, southwest, all the 4 quadrants. So that's the simple quad tree. And then you can see that it is a constructor which will create everything for us, and it has a subdivide method. So what is subdivide? So you can see that it's very simple. When the subdivide is called, it is just taking all the values here and it is creating a new rectangle, okay, with all those northeast, northwest, southeast and southwest value with the half of the values. Okay, so whenever I am just subdividing, I am just subdividing all those values. So suppose I have point 0, 0, okay, and I have 200 width, 200 height. Okay, so my point here will be minus 100, 100, 100, 100, minus 100, minus 100, minus 100, sorry, plus 100 and minus 100. Okay, so you can see that my center point, now I'm dividing into 4 central point for the 4 different quadrants. So that's the calculation over here, that x plus w, y plus h, x minus w, y plus h, and everything divided by 2. Okay, so that's the entire calculation, entire quad separation that I'm doing here. So this is what I'm dividing the entire region into sub-region into 4 parts, and I am assigning the quad tree here, and then I'm defining that it is divided. Okay, so now you can see that the main entire thing, this is subdivided, so it's subdivided equal to true, and it will have the 4 reference to each and everything. Now again, if we divide, it can again go and subdivide. So that's the code for this, and you can see that it's an insert method. So this is what we have already covered. So what it checks is, it takes a point P and it will check that if that point is within the boundary or not. If you can see that it's not within the boundary, it will return false. If it's within the boundary, then it will check that if it's within the capacity or not. If it's within the capacity, then it will add the point and it will return true. If it's not within the capacity, if your capacity is full for that quad tree, you need to again subdivide. So in the else part, if it's not divided, you go and subdivide. Okay, if it is already subdivided, then you will go and check in the respective 4 quadrants. If it's not subdivided, then you subdivide and then you can go and insert the data. Okay, so that's how you will do completely. And at the end, if you have still not got anything, that means there is no points available. There is no point of inserting the data because it is outside and you can directly return false. So this is the how insert works. Now let's go ahead and check the query. So within the check query, you can see that you are just passed a rectangle, that this is my rectangle. Okay, this is what I want to search for. So within my range, I want to search within this range. That's what I am giving here. So I'm giving a range and I'm giving a points to be found. So I'm first simple check that this particular rectangle, this particular range is within the boundary or not. If it's within the boundary, if it intersects, then only I can do something. So you can see that if it does not intersect, then return. We cannot do anything. But if it intersects, then collect all the points. Okay, directly. Collect all the points directly. Now you have collected all the points. Then check that if this particular quadrant or this particular rectangle is subdivided. If it's subdivided, then go and check for all those particular quadrants. because every time whenever it's divided, it will have 4 subquadrants. So it's simple. If it's divided, go and check for all subquadrants. Then again recursively it will check for all the subquadrants and you will get a list of points available. This will be checked until it is divided equals to false. So this is how the entire structure, entire quad tree will work. You can see that this is a simple code we have written here, that you have given a boundary, you have given a quad tree with a capacity of 4. And you can see that you have given a number of points. So you are adding number of points within the minus 200 to plus 200 points. And you are trying to find all the points within this range. Okay, so that's a simple code that we have written. Let's try to run this. So you can see that it has created a boundary. You can see that it has created all those sub boundaries, sub quad trees as well. And at the end you can see that there are 4 points available within this range. Now every time this particular range will differ because you are giving a random value to add the points. So if I run it again, okay, so now you can see that it's 8. I have written one more code here as a visualizer. So what I have done is, whatever we have been visualizing here to create a quad tree, we have created a Java code to have that as well, to represent that. So let's try to run that as well. So we'll be able to see how that particular thing works. So let's run this code. So you can see that this is a quad tree visualizer and this is my entire region, and this region is subdivided into multiple things. So now suppose I want to add a point or I want to add a driver here. Okay, so when I add a driver, what I have mentioned is that this particular quadrant, every quadrant has a 1 capacity. So I can add 1 capacity here. You can see that 1 point is added. Now if I try to insert one more point, what it has to do is it will check that if that point contains within that particular region or not. If it contains within that region and if it has maximum capacity, then it will subdivide. So now you can see that this point, whatever I'm trying to add here is within the range and it has reached the maximum capacity, then it will subdivide and insert it. So the moment I click here, it will subdivide. You can see that it's subdivided and added into this quadrant. Again, if I add here one more, you can see that it again subdivided. If I add one more here, you can see again it's subdivided. One more, again subdivide. One more, again subdivide. One more, again subdivide. So you can see that continuously it is subdividing and inserting the data and creating the quad tree internally. So this is how the entire quad tree works. So it will try to create infinite number of quads. I have one more visualizer as well, so that would also help you. So I'll add the link as well. So you can see this is a very similar quad tree example. And if you see here, this is how the quad tree would look like. Okay, so whatever the quad tree or whatever the data structure that you have defined here and all the points below is the quad tree, that is representation of the above. So every node has its 4 quads and that node will also have its own 4 quads, and at the end it will have the data. So you can see that this is a representation. So if I select anything, you can see it will go and select that particular point where it represents. So this is how the entire quad tree works, and you should know that how to implement a quad tree and where this particular quad tree has been useful. So you can see it's very simple to understand. This is nothing rocket science. You can see every node has a 4 point and that 4 point will be subdivided until and unless you gain a particular minimum range. That's the only thing. And whenever you want to search, you go and search until you find the minimum point. You can also do the reverse as well to fetch data and grow your radius to get more data. This is also something that we will see later in the GeoHash video. So this is everything that I wanted to share with you about the quad trees. If you like this video, then give us a thumbs up and subscribe to my channel for the upcoming videos. You can also click the join button to join my channel and support me. Please share this video with your friends and colleagues who are interested in learning system design and learning all these different awesome algorithms. Your like and subscribe will really help me and really motivate me to creating all such great videos. So that's been it. I will see you in the next video. Till then, happy coding. Bye bye.